Hi, welcome back to the class, R for Journalists. We are still talking about wrangling data, how to analyze and transform it. In the previous video, we talked about filtering, arranging, and selecting. And in this video, we're going to go over how to mutate data, how to summarize it, and how to group it up. So, we're still working with the murders data frame. Be sure to refer to the last video to pull in that data and get where we are. So let's see, we're now talking about mutate, and that creates a new variable or column with a particular function. So the way that looks is you start with the function mutate, and you pass it the name of the data frame you want to mutate from, and then you give it a name of a new variable and function to a specific argument you want to use. So for example, let's create a new data frame called murders version 2, var2, arrow mutate, when first argument is murders. And the new column I want to create is called age difference. And I'm going to subtract offender age from victim age. And that's just math. So I've gone from 47 variables to 48. And when I take a look at it, there we go, we age different. 7 years older, 10 years younger, 23 years younger. So there's a lot of math you can do really easily. It's, plus, minus, multiplication is star, divide is slash, exponentiation is the up caret. And you can do more than one. So I can do comma is how you separate it. So new column is equal to vic age minus offender age, if that's what I wanted to do. So there are two variables being created in the mutate function, separated by two commas. One is age difference. Oh, so another thing you can do is another thing you can use with mutate is this function called case when. I'm a big fan of that. You can use case when in mutate to create new values based on other values in the data frame. It's kind of like an if-else statement. So let's create a new column. Where did it go? Bring my code back. I'm going to add to it. I'll keep that one just so you can see what it was. I'm going to pretty much keep layering on what I'm doing. So version 3, I'm going to keep age difference as a column, but add a new one, which would be victim category. And I'm going to pass equals case 1, so I can use more than one. I can use functions instead of just math. Case 1, press enter to kind of, it's good for organization and readability. So if vic race label is equal to white, then vic category tilde is going to be white, and then separate it with a comma. Otherwise, if vic race label equals or is not equal to white, then tilde non-white. And then fortunately the parenthesis already was built into it. So I just leave that alone, run that. I've got 49 variables. Scroll to the right. So non-white, 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 white, etc. So you can see how that lines up. Non-white, 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 white. Okay. So you see, this is what I was talking about. We've got two new variables. One is murders. sorry, one is age difference, and the other one is Vic category. And we use case 1 to help differentiate that. So this is an example of a vectorized function in action. There are some really great ones like lag and lead and rank. And we might get into them later. In the meantime, there's a list that is linked in the code through. Another great function we can use that's unrelated to a lot of these is rename. And that's if I want to rename a variable or a column name. So let's take a look at df3 narrow again, but use a function call names. I've got state, agency, solve label, solve value, year, etc. Let's change a couple of them by just df3. I'm going to create a new data frame called df3 renamed. Use the function rename. Pass it the name of the data frame, and then comma. I'm going to press enter to just so it's readable. The new column I want to call is called offender gender equals well, hold on. Let's say I want to call, well, this is kind of diverting a little bit from the data set that we're working with in the data frame that I created in this one. So I'm just going to, you're going to have to follow along with the code, but see what I'm doing here. I want to rename solved offender, solved label. And solved label is the old one. The new one will be solved. Okay. Comma. I'm going to do month label to month. So month equals month label. df3 renamed. Let's take a look. Okay, so now we have year, month. So column names df3 narrow. You can double check. Oh, it was df3 renamed, right? Okay. So solved label is now solved. Month label is now month. Another thing you can do is you can rename using the select function from before. So let's say I want to now keep, and this is how I can also get rid of some columns while also renaming them at the same time. So it's just a way of being more efficient with your code. So let's try df4 renamed, and this time use select df3 narrow, and it's pretty much the exact same code as before, but this time I'm going to keep state comma. So you can see it's the same thing as this concept as rename, which is on the left side is the new name of the column, right side is the original name of the column. But this time I'm passing it a new column that I want to keep. So let's take a look at that. df4 renamed has 3 variables, and it's got state, solved, and month. So this is a way to deal with that. So the next big verb I want to talk about is summarize. And you can aggregate your table that way. It's the equivalent of making a pivot table in Excel. You're aggregating the whole table into something simplified. So for example, summarize, and you pass it the data frame, first argument, and I'm going to create a new column name variable called average victim age equals mean vic age. 48 years old. So what if I want to create a table of summaries? I can reuse this code, and this time I want the average age, average offender age, sorry, equals mean of age. Oh, here we go. There's that issue again with with really ancient offenders. And that's because we need to filter out all those 999s again. So before, let me do murders filtered is the new data frame. Filter off age doesn't equal 999. Oh, I need to pass the name of the data frame. Okay, and now I can pass in this new name, this new data frame that we've got that's filtered, and use the same code we had before. Okay, and so the average age of the offender is 31 years old. You can also do more summaries. Let's say I wanted to find the max of something or the min of something, and also the count of something. You can do that in pivot tables, and this is how you can do it in R with dplyr, and that's summarize murders filtered, and this I'm going to do first equals min year, because I want to see the earliest the data shows up. I want to find the latest of the year, and max is the year. Max is the function to find the highest of something in the data, and I'm going to create a new variable called metro areas equals, and the function here to find the count of something is n_distinct. And I'm going to pass on the variable MSA label, and then one more. How many cases they've got, how many cases there are in this data set. So cases equals n parentheses. That just means the number of something. So let's take a look at that. Okay, we have a nice summarized table, which is the first year in the data set is 1976. The last year is 2016. The metro areas, there are 409, and out of the cases that were filtered, we've got 500,000. The next verb I want to talk about is group by. This is very powerful. It's how you can aggregate data before you summarize it. So let's take the same thing we did before, modify it a bit. So what if we first took murders? We're going to work with murders this time and not murders filtered. Okay, so let's just leave that blank. So murders, but this time I'm going to group by. Okay, the first thing I pass to it is the name of murders. And this time it's going to be MSA label. I want to group by MSA labels all the metro statistical areas first before I summarize it, and you'll see why. And then now I can pass on the new data frame, which has been summarized. And this time when I do, because I've already grouped it previously, when I do all this, I'm going to get rid of this first real quick. Now, when I summarize murders, because I've grouped it first, now I get variables. Now every single MSA group is a row, and there's variables for each one as it applies to them. It looks like first and last year are all the same, but cases now are distinctly different. There are 366 cases in Abilene, Texas, 2,374 in Albuquerque, New Mexico. So this might be a tough concept to understand at first, but we'll go over a few more examples, so it will hopefully make more sense. So let's get over some very useful functionality that comes with the dplyr package, and that's pipes. And we're going to actually go over that in the next video because it's quite involved, and we're also going to talk about mutate and group bys, and it's going to be pretty much more in depth. So just to recap, we have gone over mutate, we've gone over summarize, and we've gone over group by, at least an introduction to that. So I'll see you in the next video.